Lesson 119 is on something called the quadratic formula. Now, as you get towards the end of this book, these concepts will be covered again in quite a bit of detail in Algebra 2. So you're just getting introduced to them here. I know if you're doing a regular school year, it's almost summer, you got 2 lessons left. You may not be really that into math anymore, but I want you to try. Just keep trying. If you do your best to the very end, it's just going to make it easier next year. So try to keep focused, do your best on this lesson and your next one. Now, the standard form of a quadratic equation, we've talked about that a lot, and that's ax squared plus bx plus c equals 0. Now, we could apply what we just learned in Lesson 118, which was completing the square. We could do the completing the square method on this standard form here, and we would end up with a formula that would allow us to solve for any quadratic equation just by substituting in the coefficients in the right places. So let's go ahead and solve this quadratic equation here, the standard form, using completing the square method. So we'll have a x squared plus bx equals a negative c. Now, keep in mind that in the previous lesson, whenever we solved using completing the square method, our x squared term was always by itself. It had a coefficient of 1. So we've got an a in front. We need to get rid of that a. So that means we need to divide every term by a. And so then we'll end up with x squared plus b over a times x is equal to minus c over a. Now we're ready to complete the square. Remember what we do there. We take half of the x coefficient, which is b over a. Now think about that. Half of b over a. That's like saying half times b over a. So that would be equal to b over 2a. So that's what we put. Well, actually, we need to square that, right? We need to square that value, and so that'll be b squared over 4a squared. And that's what we add to both sides. And so we'll put plus b squared over 4a squared, and then b squared over 4a squared. We add that to both sides. We take half the x coefficient, b over 2a, square that, we end up with b squared over 4a squared. Add that to both sides. Now we can complete the square. We can make a squared binomial on the left, which will be equal to x plus half of the x coefficient, b over 2a, is equal to b squared over 4a squared minus c over a. Now we need to add those two together, so we need to multiply c over a by 4a over 4a in order to get a common denominator. And so that would give us b squared over, or b squared minus 4ac all over 4a squared. And I forgot to put the squared term there on the left, that exponent of 2. Now, the next step is to isolate x. We do that by taking the square root of both sides. Okay, so now we have x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac over the square root of 4a squared. And then lastly, we solve for x. X is equal to negative b over 2a plus or minus the square root of b squared minus 4ac, and then the square root of 4a squared would just simplify to 2a. So there's our quadratic formula. That's a formula that we can use for any quadratic equation. We can substitute our a, our b, and our c in for whatever that quadratic equation is, and we can solve for the roots. Now, when you use that quadratic formula, usually it's written with one denominator, everything over that common denominator of 2a. So here it is, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The sooner you memorize that formula right there, the easier your math is going to be in Algebra 2. There are lots of times when you'll be using that equation. Let's use the quadratic formula to solve a quadratic equation. Look at practice problem A. 2x squared plus 3x minus 5 equals 0. So all we do is we substitute those coefficients of x squared, x, and then the constant into the quadratic formula as we need to. And so we start out, we'll just say x equals, just follow the quadratic formula that's right above there. Negative b. b is equal to 3. Actually, first, let's do this. Let's write down the standard form directly underneath our quadratic equation. Ax squared plus bx plus c equals 0. That will help us think about what to substitute into the quadratic formula. And we can line up the a and the 2, the b and the 3, the c and the negative 5. That's a good idea to do first. So negative b, we see that that is a 3. So we'll say negative 3 plus or minus the square root of b squared, so that would be 9, minus 4 times a, which is 2, times c, which is negative 5. And then all of that is over 2 times a, or 2 times 2, which is 4. Okay, so we can simplify this now. X is equal to negative 3 plus or minus the square root of 9 minus 4 times 2 is 8 times a negative 5. That would be a positive 40. So plus 40 all over 4. Now, simplify that even further. Negative 3 plus or minus the square root of 49. That would just be a 7, wouldn't it? Square root of 49 is 7 all over 4. Okay, so we can write this as two fractions. Negative 3 plus 7, which would be 4 over 4. So that's just going to be a 1. So we can say x equals 1. And then our other root would be negative 3 minus 7, which is a negative 10 over 4, or a negative 5 halves. Those are the roots for that quadratic equation. 1 and negative 5 halves. Let's do one more. Negative 3x squared plus 2x plus 1 equals 0. Let's solve that using the quadratic formula. So what we want to do first is write our standard form underneath it. That will help us. We'll use that as a guide to help us remember what a is, what b is, and what c is. And then let's go ahead and write down the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Memorize that formula. Now you can go ahead and substitute in where you need to. X is equal to negative b, and we can see that b is equal to 2, so we would put a negative 2 plus or minus the square root of 2 squared, which would be 4, minus 4 times a is a negative 3, put that in parentheses, times c, which is just 1, all over 2 times a, so that would be 2 times negative 3, or negative 6. Now go ahead and simplify. X is equal to negative 2 plus or minus the square root of 4 plus 12 all over negative 6. And so that's going to equal negative 2 plus or minus the square root of 16, which would just be 4, right? All over negative 6. Now, these aren't always going to simplify into two rational number fractions. Sometimes they'll have that square root you can't simplify anymore. Like if it was 4 plus 13, that would be a square root of 17. You wouldn't have been able to simplify that any further. But since it is all rational numbers here, let's go ahead and continue to simplify. And so we would say x is equal to negative 2 plus 4. That would be a 2 over negative 6, or negative 1/3. And then negative 2 minus 4, which would be a negative 6 over negative 6, which is a positive 1. So those are the roots, or zeros, for that quadratic equation that we have above. We can always check our work. Let's substitute a 1 back in to that equation. We'd have negative 3 times 1 is a negative 3, plus 2, which would be negative 1 if we added those together, plus a 1, that equals 0. So that did work there. Checking our work gives us confidence that we did the solution correctly. Memorize this formula that I'm circling in blue. Make sure you memorize that quadratic formula. Okay, well that's all for lesson 119.